What's going on, everybody? Welcome to this live stream where we are going to code an Apache Spark project from scratch. Let me check if everything's working. If so, please leave a comment or write a comment so that I know that everything's working correctly, that you can understand me well, and that my video is fine. Otherwise, I can only see your comments, hopefully here. And in this live stream today, we are going to do some live coding, and we are going to start with setting up a development environment from scratch. And I'm going to use a local IDE. I will use IntelliJ, setting up a Spark dependency, and then we will get some example data. We are going to use the stock market data set, as I have used it a lot of times in video tutorials. And then we're going to read this data as CSV in the correct format with the correct data types and column names and so on. And then we are going to build a simple use case using the Apache Spark SQL API. And depending on how fast we are going to be, I will write a test, and then I will answer all of the questions that you may have. So whenever someone's here, please let me know if everything's working fine on the LinkedIn site. Otherwise, I will just get started. Some of you may have been on the live event that I had just before, 1 hour before, with Andreas Kretz, where we've been talking about learning Apache Spark. I've shown the detailed roadmap, and I've given some recommendations about how to learn Spark, how to craft your individual learning journey. And if this video will be available on YouTube and LinkedIn, so if you're interested in learning Spark and trying to figure out a roadmap for yourself, check this out as well. Otherwise, I haven't heard anything yet in the comments, but I think we are good to go. So let's get started. Thanks, Sebastian. Good to have you here. So let's get started. As usual, I will basically create a new project, which we're going to work with. And therefore, I'm going to use the IntelliJ IDE, and we'll simply create a new project. Also, let me know if you can read everything on the screen. And I'm going to call this PySpark Live-Coding and create it in a directory. We're going to use Python, so PySpark, with a new virtual environment, which will be created in our project directory. And the only thing we need is basically a Python interpreter, which is basically selected from my system here. And one thing I wanted to show you in the Spark documentation is that it works with Python. We're going to see it here. So if you go to apache.spark.org, and then documentation, latest release will be 3.5.0. And here we can see under the section downloading, we can see that Spark actually runs with Python 3.8 or newer, and therefore we are going to use 3.9. So that's a very good source of information about Apache Spark. It's actually the official documentation, and you know how to find this information now. So I'm going to use 3.9 and create a new project. And here we go. We have a basic Python project in IntelliJ. And the next thing we will have to do is actually to set up a Spark dependency so that we can use it with Python. Maybe, I think it's good readable, but I will enter presentation mode so it will be even larger. All right, let me create a file which we're going to call requirements.txt. And that's basically how we manage dependencies, library dependencies in Python. And for now, the only thing we are going to need is PySpark. And we are going to use the version 3.5.0. And as I'm using an IDE and it knows we're using Python and a virtual environment, it already suggests me that it can install this dependency for me. So if I hit Alt and Enter on my key map, it suggests me to install it for me. However, I would like to show it to you from the command line, because I'm aware that some people have a free version of IntelliJ, and that doesn't allow to automatically install dependencies with pip. And therefore, I will actually simply go to the project directory. And for me, it's within Professional Workspace and then PySpark Live-Coding. So I go here and I simply execute or activate the virtual environment which has been created for me. So the IDE has already created the venv folder here, which is the virtual environment. And this one we have to activate. And therefore I say source and then venv bin activate, which will get us into the virtual environment. And here we have a project local Python installation. And if I say which Python 3, it will actually tell me that we are using Python from our project directory here. So it's within PySpark Live-Coding and then the venv, and that's the Python interpreter we are using within this virtual environment. Now, as I have activated this virtual environment, we can now go ahead and install the dependencies. Therefore, I use Python -m pip. So we use the pip package and say install -r. So we are specifying that, or we're telling Python that we're going to use a requirements file. And then I put the file name here. So on this command here will install the requirements in my virtual environment. And I have a small typo here. So let me get here. I need an S. And now it's downloading the PySpark dependency to my virtual environment. And if we look into this virtual environment now, we will see that within, I think, lib, there should be a PySpark dependency now, and here it is. So these dependencies have been added within our project here. So that's basically, let me think, I think that's the setup we need to implement a Spark application locally here on our laptops. And I'm going to run the Python files we're going to create from this IDE here. But for now, we have everything satisfied. Also, the IDE is not complaining anymore. So all the dependencies are here. If you are doing it that way, sometimes you will have to refresh your project from disk. And there's a button down here which says reload from disk, so that it fetches the changes we have made outside the IDE into the IDE, so that it knows that the dependency is here. Now, to get started, actually, I would like to start with a simple hello world. And I like to have a directory for PySpark projects, which is called source. And within the source directory, I will put all the source files, so the Python files. So now within the source directory, I will create a file, basically a Python file, which we are going to name hello world. And in Python, it's best practice to use this snake case here. And now the first step within our Python module will be to instantiate a Spark session if we are running it locally. And I've seen there is a question now. Actually, the video will be available afterwards. I will upload it to YouTube as well, so you can follow up there. All right, let's get started with our small hello world example. First of all, we can let me close this one. So hello world, we can print hello world simply by running a Python module here. And on the command line, we will see that it has printed hello world. However, we would like to use Spark, and therefore we need to instantiate a Spark session, and we're going to call it Spark as in a Databricks notebook. So if you are using Databricks and you're referring to Spark, that's basically a Spark session that has already been instantiated for you. Now, in order to use the Spark session, we have to import this one. So we say from PySpark.sql, import the Spark session. All right. So the Spark session has a builder, which we are going to use to instantiate a Spark session. So within the builder, we can pass some configuration. So the first one would be, for example, the app name. We simply call it Hello Spark. And we can also pass in the master, and these two are basically the most essential configuration parameters we need if we instantiate or run the Spark session locally. And here we're going to put local and then in brackets an asterisk, which will actually instantiate a single JVM on my laptop and will use as parallelism as many cores that I have on my machine. So the asterisk stands for the cores that I have available on my local laptop where I'm going to run this application. And then finally, on the builder, we can call get or create, which will actually return a Spark session, as we can see here from the documentation as well. So what I just did was actually only to press Command and B, which will resolve this get or create method, and we can see how it's implemented in the Spark or in the PySpark API. All of that, what's happening here, we can also look up in the official documentation. So if I go to the browser and API docs, and we are going to use Python, you can find a lot of valuable information here. And there's also the API reference. And within here, today we are going to use Spark SQL only. And here's also the Spark session, which we have used just before. And usually you can find some examples here as well. So there is a builder, for example. Let me see. Builder.appname, that's what we use, for example, or config. Also, there are user guides. And if we go to Spark SQL, there are also some very important, there's also a lot of very important information. You can read through all of these things as you are getting started with Spark. I will simply focus on building something here so that you can watch and do it yourself afterwards. Now that we have a Spark session, we can use it, for example, to print the Spark version, which is basically the hello world within PySpark. So that will, if that works, we will know that the Spark session has been instantiated and the dependencies there and so on. So if I execute my Python module now, it should work and print the version of Spark. So now we will see in the Spark log statements as well. And now we have the hello world string here and the 3.5.0, which is the version we are using. All right. So having that said, we would like to work with some data, and therefore I will go ahead and download some data. And probably, or maybe you have heard about that I use Kaggle to get data sets. And here we have the stock market data set. That's a data set that I like to use for simple use cases. So here we have basically CSV files for many stocks. And I use something with A. Usually I use Apple because it's in the top here. And here we can see already the what's in the file. So we have a date column, and then we have an open price, a high price, a low price, a close price. So for every day, we have one data point, which is one row in our data set. Sorry, I just hit the back button. Here we go. And this one I would like to download and to put into our project directory. Therefore, I will create a directory called data. That's where we're going to put the data. And then I will actually go to the downloads folder and unzip the zip file here. And now we have the CSV file, and that one we would like to move to basically professional workspace PySpark Live-Coding, and then data. So that has been moved. And now within our ID, we should be able to see it. So here's the data directory, and we have the CSV file. We can tell already that it has a header and then all of the data here. Now, what we would like to do with that file is to read it from Spark. And we would like to read it in that way that we have the correct column names and we have the correct data types. Now, if I go ahead and use the Spark session, and the Spark session is, as you may know, the central entry point to every Spark application. So we use the Spark session always to get a new data frame. So an abstraction which actually holds the data. So on the Spark session, we can call .read, and this will actually return a data frame reader. And this data frame reader, if I resolve this again, has methods for loading data from disk. So from multiple file formats, for example, CSV. Let me check if I can. So if I resolve the data frame reader and hit Command N7, we get the structure here. And here's the data frame reader. And here it shows me which methods are available on a data frame reader. So for example, we have the JSON method or the load method, also the CSV method, which we're going to use here. We can also connect to a JDBC, a relational database, or Parquet and these things. So that's all of that is defined on a data frame reader, and we can retrieve a data frame reader by calling spark.read. And on that, we can call, for example, CSV, and this takes arguments, and one of the arguments is the path. So we have to specify a file system path from where to read the CSV data. And here I would simply use a relative path starting from the root directory of our project. So in our case, it would be data, and then I was afraid that something had crashed. We would simply load the apple.csv file, and this will already return us a data frame. And on a data frame, we can call show, which will print the first 20 lines of the data frame to the console. And now we will encounter an error, probably. So now we have encountered an error, and it actually says path not found. So the path doesn't exist. And if we look at the path that it's trying to use here, we can see that the Python, that it's actually creating an absolute path from our relative path. And as we are in the source directory, it will simply add our relative path to the source directory, which is incorrect. And I would like to show you how to fix it. So if I open up the run configurations, that has been automatically created from the IDE for me when I hit the play button. And it also basically specifies what's happening if I hit the play button, and it's actually executing this Python script here, hello world, which is in the source directory. Now, as a working directory, it's a little bit bad formatted here now. Okay, I can't see anything. Let me. Okay, 1 second. The problem is that the working directory is actually the directory where the source file resides. And we need to fix the working directory for our run configuration. So here we can see now the working directory is the source folder, but we would like to have the working directory as the project's root. So if we do that, that will work. Also in IntelliJ and other IDEs as well, you can edit run configuration templates. So for Python, which we are using, we can set in the template the working directory. And here I would simply like to paste this path here so that the next time I press the play button in a different source file, for example, and a new run configuration gets created for me, it will already have the correct working directory set. And that should work now. And to prove it, I can delete this one and simply run this script again, which will create a new run configuration. And now it should be able to find our CSV file here. There are no questions yet. All right, so we have loaded the CSV file, but now we can see that it didn't pick up the header, but rather the header became the first row in our data frame. And therefore, I would like to show you some options we have when loading a CSV file. So first of all, we can look at the definition of this method here and see which options we have. So all of these things we can pass directly into the CSV file method, into the CSV method. So if we read this code out loud here, we are defining a new method in the data frame reader, and it has, for example, a parameter called infer schema, and the type is either a Boolean or a string, and by default it's none. So it's, if we don't pass anything, it's going to pass none. So per default it's going to be false, which we can see in the documentation. Let me head over to the documentation. SQL. I don't know for PySpark where to find this documentation, but there is a documentation about all of the options and their defaults and what they mean. I will have to send you a link, or I can show you for Scala, but for now I don't know. Anyway, let me head over to the Scala part. So latest release, and then AP programming guides. It's in programming guides, SQL, and then data sources. And here we have these CSV files. Here are some examples which you can use as well for your reference. And below here is a table of the parameters we can use when using this method. And for example, we have infer schema. And the second column here is the default value, and it's set to false. And also the header is set to false. Now we could use these two options to actually fix both of the problems, because what I also wanted to show you is, even if we say header is true, it will not actually infer the correct schema for us. So on the df, so I've now stored the data frame into a variable, and on the df I can now call print schema, which will print the schema to the command line. And if I execute this one now, we would have the correct column names coming from the header, because that's the first line in the CSV file, but it will basically have all of the columns be of type string. So here we can see the date is a string and the open price is a string and so on. That's because it doesn't per default try to figure out the schema, which is good. I will explain later. But for now, we can set infer schema to true as well. All right, if we now print the schema and then DDF, we should have a good result. So why is it bad, or why is infer schema set to false per default? It's actually the case that Spark has to scan the entire CSV file, so all lines within the CSV files, to figure out the correct data type for each of the columns, which of course is costly. So we can do this for now just to play around with the data. And now we can see that the schema is correct. So the date has type date and the open column has type double and so on. But as we are implementing larger applications or reading larger files, or if you just like to build a decent Spark application, we should pass in a explicit schema when reading a CSV file. Yes, I can increase the font size. So either pass in an explicit schema or let it infer the schema. However, that costs a lot of performance. All right, So we have read our CSV file. We have a data frame. Now we could, for example, rename the columns. I like to have them in lower camel case usually, so that we could do. Or we could also just play around with it a little bit. For example, say df, and then what can we do? We can use a column. For example, we use the column function, and we just take the column date, and we want to cast it to a string. And therefore, I would need to import this function here from PySpark.sql import, no, SQL functions import column, for example. And using this column function, we retrieve, or we are actually trying to retrieve a column called date. And we don't have to specify a data frame. We're simply assuming that it's there. And the first step in the logical planning when we execute our query will actually try to resolve this column from the data frame we call our expression on later on. So now we have a column, and now we can say, for example, .cast, and we have to pass in a data type, which we would like to cast the date column to. And for example, I would like to use a string type, and that we would have to import as well. And that we can find from SQL.types, and then the string type. So we pass in the string type here and cast the date column to a string type. Now on that column, that gives us a column in turn. So if we look at the cast method here, it returns another column. So we can just keep on adding transformations on that very column. So for example, we can concatenate this column. Therefore, we need to import the concat function as well. Let me import it here, concat. That's coming from the SQL functions as well. We can concat this casted string column with another string, for example, hello world. That would give us a column transformation. So we are transforming the column twice, and we can store, for example, this transformation in a variable. For example, cast date, call it expression. And now we can use this column transformation on our data frame df by simply saying df, and it has a method with column, which basically adds a new column to our data frame. We say we have to specify the column name as the first parameter here. We say new date, and then we pass in our cast date expression. So we could have put this entire thing here after the equal sign into our new with column method, but we have stored it in a variable, which makes it quite nice to structure our code, because we can actually assign a name to a transformation. For example, cast the date column, if there is any, to a string, and concatenate it with another string, and that will be a new column called new date, and on that we can call the .show method, for example. So if I execute this, we would expect to see our data frame with one additional column appended. Okay, please shoot any question if you have any, and I will try to answer them. Okay, here's our show, and then we have an error here, and it says, okay, I understand. So it says a column or function parameter with the name hello world cannot be resolved. And I would like to explain to you why that is. So if we look at the concat function, which is coming from the functions. So we have imported this one from PySpark.sql.functions, and then there's the concat function. It takes a variable length argument of a column or a column name. So we can pass in either a column reference or a string, which is supposed to be a column name. However, what I tried to do here was to pass in a string as a literal. However, that's not a column in our data frame. That's why it doesn't work. What we need is to make this a literal. So that will be a column consisting only of that one value here. And for me, these Python imports usually don't, it does. So I've imported that one now. So now we are concatenating the casted date column with a column which only contains the value hello world in every row. And now this should work. All right, so if you don't have any questions, I will simply go ahead and play around. I would implement a small functionality. So here we can see our new column, which has been added. It has the name new date, as expected. So if you don't have any questions, I will go ahead and first we'll restructure the code. Or I will first implement a small use case. So what we would like to do is to find the highest closing prices per year from our data frame. As you recall, we have one row per date, and we want to find the date with the highest closing price in each of the years, and we would like to have the entire row. So we would like to see all the values, not simply the year and the highest closing price, but we would also like to see the exact date. And therefore, we will have to use a window function. I cannot explain everything in detail here about window functions. I would just go ahead and code something. If you have questions, please ask them. So we are going to use a window, which we have to import. And now it doesn't work again. So it's coming from the SQL package as well. So from the SQL package, we import Spark Session and window, and now we can use it. And a window is basically a window over our data. And we are going to use two properties of a window. First of all, the partition by, where we can specify how we would like to partition or group basically our data frame. And here I would like to use the year of the column date. So what we do is basically to extract the year from the date, and we partition by the year. This year function I have to import. It's coming from the SQL functions as well. And then within each of the windows, we would like to order our data, and we would like to have the highest closing prices first. Therefore, I use the column close, and I will have to use uppercase letters because we haven't renamed our columns. So we use the column close, and we would like to have them sorted descendingly. So what's happening is we create a window for each of the years. So each of the windows contains only rows of one particular year. And then within each of the windows, we order the rows by the descending closing price. And then the first row in our window will always be the date with the highest closing price in the year. Now that's only a window specification. The question is, how can we apply this window specification to any function on our data frame? Now, in order to apply this function, we will use our data frame df and say with column. So we are adding another column. We have to specify a column name again. We're going to call it rank. And then what we would like to do is to actually number all of the rows in our window by their ordering in the window. So once we have the ordered window, we assign each of the rows in the window a number, which is increasing. So from 1 to x of the rows. And we can, on this row number function, we can call over. And here into the over method, we can pass in a window specification. Now, let me show you quickly how you know whether it's a or what the window functions are. So as we have seen, we are at that's Scala again now. So here's the Python API reference, and we have been using the functions. So here, so as a PySpark.sql.functions, you will find all the function definitions which you can use. So in this document, you can see there are hundreds and hundreds of functions you can use to transform columns. And one section of them is window functions. And here you can see all the functions on which you can call the .over method, which takes a window specification. So all of these functions work with a window specification, one of them being row number, which basically returns a sequential number starting at 1 within the window partition. And that's exactly what we need. Now let me go back to our code here. Let me see if I can move this up. So we are creating a new column rank, and in this rank will be the row number for each of the rows over the window. And what we would like to have is basically only those rows where the rank column, so the rank column equals 1. So only the first row within each of the windows will yield the row with the highest closing price per year. And then we can also drop this column rank again. We won't need it again. And then, for example, we can say .show. And in Python, we have to, if we use multi-line statements, we will have to use this escape character here in the end to tell the interpreter that the line continues actually. And that should give us the highest closing prices per year. So next up, I will restructure the code so that we can write a test. However, as we are 38 minutes in, 36, maybe we can do it. All right, let me see. So we have one row for 1980, one row for 1981, one row for 1982, along with the whole highest closing prices. And as you can see, the dates vary. So in 1981, it was the 2nd of January, and 1980 was the 29th of December. So probably after January, it has dropped again. Whatever, that's our functionality. But as you can see, it's not, how can we tell that it's correct? I don't know. I haven't looked at the data for 1980. I don't know whether this was the highest closing price. So we could look into our data frame or into our CSV data, whether this is actually the highest closing price. But we can also write a test with small example data. And that's what I would like to do now. So therefore, as I said, I would like to restructure the code so that we can use this method here. So I would like to have a method which is called highest close price per year, and it takes the data frame. And I, as I said before, I like to have explicit types, and actually returns a data frame. And now we have to import the data frame as well. We haven't used it yet. Now I messed it up. And now we don't like to show, but rather we would like to return our result to the caller. And let me see if it can pick this up. No. So from the PySpark.sql, we can also import the data frame. Now it should work. And now it asks me to reformat the file. So there should be 2 lines before a method definition in Python. And yeah, well, this method we can now use from within our test case, and we can pass in a data frame we have constructed in our test case. And then we will get back a different data frame, so the transformed data frame, on which we can run assertions. So in order to do that in Python, I will create a new directory in this project here. I'm going to call it tests, and within there, I will create a Python file, and I'm going to call it highest closing price test.py. it would be better to write it out. Now, to implement a unit test in Python, we would import unit test, and for our test suite, we will define a new class, and I call it highest close price test. And here it should be a child class of the unit test case. So that will make it inherit some of the things we need, so that the Python interpreter knows that we are going to execute a test case. Now, to write a test, we simply call it test, and then I call it without ties, so there are no tied data rows. We don't have defined a tiebreaker now if the close price is exactly the same. So one test could actually test the scenario where we don't have any ties. Now, within that, we would like to call basically the highest closing price method with a data frame. And therefore, we have to import from source hello world import highest closing price per year, which is the function or method we just defined. And that one we would like to call here, highest close price per year. And we have to pass in a test df, and we will get back a result df. And on that one, we would like to run an insertion such that we know that it returns the correct result. And therefore, we will have to instantiate a test df. And in order to do so, we need a Spark session. As I said before, the Spark session is always the central entry point to any Spark logic, and we use it to instantiate a new data frame also within a test case. Therefore, we will have to define a Spark session within our test case here. And therefore, I define a method which is called setUpClass. And that is actually inherited from the unit-test.test case. So we actually overriding it. And as this one is supposed to set up the class, it has to be a class method which is run before we run anything within the class. And here we can now use the class reference to actually store a new class field, which is going to be our Spark session. And here we are going to use the Spark session as well. Spark session.builder, and then we are going to import this one from PySpark.sql import Spark session. And we're going to set the app name to, for example, what do we test? HCP test. And the master, we are going to set to local of asterisk again. And then we are going to call the get or create, which will actually retrieve the Spark session. So now we have a field within our class, which is the Spark session. And within our test, we can now use the self-reference, which is the instance of the test. So it's one instantiation of the class. It now has a Spark session. And that we can use to create a data frame. And if we look at the code of the create data frame, it also gives us some examples, usually how we can use it. For example, we have to pass in a list of tuples in a sense, which will going to be the rows in our data frame. And that's what we're going to do as well. So we're going to have a list of tuples, which we're going to use, or objects. In our case, we're going to use objects because we would like the columns to have names as well. So within here, we will use, how does it? So now we need a date time. And this one we have to import because we need to instantiate dates. Datetime.datetime. Let me check. So we have a date, datetime dot date. Here we go. And we can instantiate a new date by passing in the year, the month, and the date and the day. So the year is going to be 2023. The month is going to be, let's say, January, and the day is 23 as well. And then we need at least the close price. And this one has to go into these quotes here. The close price should be, let's say, 2. So that will be our first row. And now let's also add an open price, which should be 1. So a double of 1. And then let's add a second row. And it's not going to be the 23rd, but the 24th. And let's say the close price here is 1. And the open price was 2. Now we use that as input data to our test case and create a data frame from that. That's what's happening within here. And that data frame we pass into our highest close price per year method we have defined before. And we will store the resulting data frame in the result.df. Now within here, we can also say result.df.show simply to see the result and see if it works. And we can execute this test case simply by hitting this play button here. And the IDE will actually create this run command here for us and see if it works. Okay, what do we have? Path not found. Okay. Now the problem is that we are importing this hello world example here. And there's a lot of code which we actually don't need. And yeah, it's a bad idea to structure code like this. So I will simply clean it up quickly. I will say I created I define a new method here, which we're going to call init spark. And within that goes all of that. There we don't need. And then let's say we have a method main, which is going to be this here. Init spark, so that we don't have code dangling around here in our Python module here, because otherwise it will be executed once we import it. And now we should be fine. So this one we don't need anymore. All right, and now let me execute this one again. So for now, we're expecting to see the result after having transformed this small data frame here consisting only of 2 rows. And we can see that the resulting row is actually the 23rd of January in 2023, and it has the higher closing price. So for our small data set, our function or method works correctly. But now we would like to assert this automatically. And therefore, I would once again refer to the PySpark documentation here, because there is also a section on testing, I think, in the user guide, Spark SQL. No, getting started. Testing PySpark here. So here is also very valuable documentation. They're doing pretty much the same as we do. So they're creating a data frame. And then there's also within PySpark built-ins using unit test here, option 2. There is actually, they have defined an assert method for us. So it's called assert data frame equal, because what we now would like to do is that we specify our expected data we would like to see, and we would like to compare it to the actual result we get. And therefore, we're going to use pyspark.testing.utils and then assert data frame equal. Let me go back to the IDE. Now, the first thing we do is we specify what we would like to see and call it expected df, so expected data frame. And we would like to see the row with the higher closing price, which is this one. And now we would like to use the assert. Let me import it first from PySpark.testing.utils import assert data frame equal. And that we would like to call here assert data frame equal. And the first argument should be the actual, as it suggests here. The actual is the actual result we get. So that's the result df. And then the expected, which is our expected df. And that should be true. And only if it's true, if the data frames are actually the same, this test will pass. And that's how you can basically test the logic you are implementing in your Spark applications. Now, we've done it correctly in this case. And yeah, that's basically what I wanted to show you. Now, I haven't seen too many questions yet. Is there anything you would like to know? Is there anything I can answer for you? Is there anything you're struggling with setting up your PySpark project? Would you like to see anything else? If not, I would like to point you towards my coaching. I'm actually offering individual live one-on-one coachings where I teach you everything I know about Apache Spark software development. I have worked with Spark in professional contexts for, I think, more than 8 years. So I came across some of the problems, and I'm happy to share this knowledge with you. You can find this coaching if you go to academy.philipp-brunnenberg.de, and you can schedule a meeting if you're interested. So we can talk about your individual roadmap, your individual goals, what you are trying to accomplish, whether it is to find a new job or to do something else. And on this page, you will also find the coaching product, which you can find down here. And we can do the coaching in any of the languages, Scala, Python, or Java. But as you're here today, I guess you are interested in Python. And yeah, there's also a small outline here, which is not very fixed. I don't know if you have participated in the previous live event with Andreas. I've shown a roadmap, and I will use this roadmap to find your individual learning journey, what you would like to learn about Spark. And we will work together for 12 weeks, having one call a week for 1 hour, where I will also review your code and teach you a lot about the internals, performance optimizations, and integrating your Spark application into clusters and with different technologies. Now, thanks that everyone has been here. I think we can call it a day. I give you a couple of more seconds to write a question. Otherwise, I would be happy if you shoot me an email with a question, or just reach out to me, schedule a call, and we can have a chat. So everyone, no, I don't know what time it is for you. For me, it's evening. I'm going to have dinner now. It's been a long day. Thanks for tuning in and having me, and see you next time. I hope you enjoyed it. See you then. Bye-bye.